बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वालैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वालैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन. In this lecture I will discuss the solutions of P1 variant 1-2 of November 2020. And for this I am using the work of an outstanding and one of my best student, Miss Ramsha of class 2022, the Lyceum. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to three significant figures or one decimal place for angles in degrees, unless a different level of accuracy is specified in the question. An important advice for me and for everyone, we should be fair to others. Two important tips for you to solve the paper in a good way. Number one, avoid careless mistakes. Number two, read the questions carefully. Question number 1. The coefficient of x cube in the expansion of is 20. First, we need to expand this expansion up to and including the term x cube. This is the expanded form of this expansion up to and including the term x cube. Now, by multiplying this expanded form with this expansion, we have this. We just need to multiply the selected terms, the terms which will give us x cube. So when we will multiply this one with this term, we'll get minus 80x cube. And when we will multiply this kx with this 40x square, we'll get 40kx cube. Now we need to equate the coefficients minus 80 plus 40k to 20. And by solving this equation, we have k, which is 2.5. Question number 2. The first, second and third terms of a GP are, this is the first, this is the second and this is the third term respectively, where P is a positive constant. Find the sum to infinity. Whenever we have three consecutive terms of GP, then we always use this formula to get the value of R. So by substituting the values of T1, T2 and T3 into this formula, we have this. And by solving this equation, we have this equation and we have the value of P6 and minus 1. Minus 1 is not required because P is positive. So we just need to reject this value. So this is the value of P, required value of P in fact. By substituting this 6 here and here, we have the first term and second term of this GP. And you know, R is T2 upon T1. So T2 is minus 12 and T1 is 18. Therefore, R is minus 2 upon 3. And this is the first term. After getting the first term and the value of R, we can easily find sum to infinite of this GP. This is the formula of sum to infinite. A is 18 and R is minus 2 upon 3. So this will become 1 plus 2 upon 3. This is the final answer. You make sure you remember this formula for three consecutive terms of GP. Question number 3. The equation of a curve is this, where m is a constant, and the equation of a line is this. Show that for all values of m, the line intersects the curve at two distinct points. Basically, we need to show this. B square minus 4ac is greater than 0. Number 1, we need to equate these two i's to get this quadratic equation. By comparing this quadratic equation with the standard quadratic equation, which is ax square bx plus c, we have the values of a, b and c. And by substituting the values of a, b and c into b square minus 4ac, we have this. And this is the simplified form of this equation. Now we just need to bring this equation into completed the square form. This is the completed the square form of this equation. You have two methods. Either use completed the square form method or use this method. You can compare this with this form. So you have two options. This is the comparing the coefficient method, and this is the completed the square method. You can do any one, and you need to get this form. After getting this form, you need to say that this term is because of this power 2 is always greater or equal to 0. And because of this 4, this entire thing will always be greater than 0, will always be positive. So because of this positive 4 and because of this power 2, this result will always be greater than 0 for all values of m. And this result represent b square minus 4ac. This is the value of b square minus 4ac. Hence b square minus 4ac is greater than 0. And this is what we had to show, that the discriminant must be positive. Question number 4. The sum Sn of the first n terms of an AP is this. The kth term in the progression is greater than 200, meaning Tk is greater than 200. Whenever we have this type of thing, then we can easily get the first term and second term and third term. So for first term, n must be 1. This is the first term. This is the sum of first two terms, 12. This is T1 plus T2 is 12. Since we have T1 5, so we can easily get T2. Therefore, T2 is 7. Make sure you understand this concept. S2 means sum of first two terms. So this is 12 and T1 is 5. So we can easily get T2, which is 7. This is for your conceptual clarity. So we can easily get D. D is T2 minus T1. 7 minus 5 will give you D, which is 2. Now, by using this thing, this formula, Tk, which is A plus K minus 1D. This is K. So in this formula, you just need to put A and D. And it is given that Tk is greater than 200. So this entire thing is greater than 200. So when you will solve this equation for k, you will get k 98.5, greater than 98.5. So according to this number line, the first possible integer value is 99. Question number 5. Find the value of fg7. First find g7. G7 will be 2. When you will put 7 here, you'll get 2. Now substitute this 2 here. So this is G7, 2, and this 2, when you will substitute this 2 here, you will get this thing. G7 is half, it's not 2. So when you will put half here, you will get 0. Let me solve this in this way. G of 7 is half. Now substitute, this is the direct method. Half here. So answer is 0. Both methods are fine, and this is the simplest way. First get the value of G7, then substitute this value here. Replace x of f by half. Your answer is 0. You can use either this method or this method. Find the values of x for which f inverse is equal to g inverse. First get the expression of f inverse and then get the expression for g inverse. This is the expression for f inverse. You all know how to find this. You just need to replace f of x by y, then make x the subject, and then replace this x by f inverse and this y by x. This is the expression for f inverse. In the same way, you can get the expression for g inverse. Now you just need to equate these two expressions for the values of x. These are the required values of x. And according to these domains, both values are fine. Question number 6. We need to prove this identity. This is so simple. First, simplify this bracket. So this tan will become sine upon cos. After taking the LCM, we have this. Here we have 1 plus sine x upon sine x. By multiplying these two expansions, we have this. This is a minus b, a plus b. This will become 1 minus sine square x, and after that it will become cos square x because of this identity. Sine square plus cos square is 1. Therefore, 1 minus sine square is cos square, which is here. By simplifying this, we have 1 upon tan x. Cos x upon sin x means 1 upon tan x. Now, we have to replace this entire thing by 1 upon tan x here. So 1 upon tan x, 2 tan square x. You need to multiply tan x here. So this will become tan cube x, and bring this to here. By taking cube root on both sides, we have this thing. This is the value of alpha. According to this domain, you have to work in first quadrant only, because tan is positive in first quadrant according to this domain. This is the final answer, up to 1 decimal place. Question number 7. The point 4 comma 7 lies on the curve, and it is given that the gradient of the tangent to the curve is this. A point moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.12. This is dx upon dt. And we need the rate of change of y coordinate, dy upon dt, when x is 4. So this is the chain rule question. First, I need dy upon dx. F prime means dy upon dx. We just need to substitute 4 here. When we will substitute 4 into this equation, we'll get 2.5. Now this is the chain rule. Dy upon dx is 0.12. Sorry, dx upon dt is 0.12. And dy upon dx is 2.5. The final answer is 0.3. The next part. Find the equation of the curve. This is so simple. By integrating this equation, we can easily get the equation of curve. So when we will integrate this, we'll get this thing. Since this equation is given in f prime x form, so we should write f of x here or y. You have choice. You can either write y here or f of x here. So it's your choice. It's given y is equal to f of x. It's better to write f of x here. Y is also fine, but f of x is better. Use the same notations. This is the required equation of the curve. So when you will integrate this term, this will become x power positive half divided by 1 upon 2. So after simplifying this, this will become 2. This will become minus 1 upon 2. And in denominator, we have minus 1 upon 2. And when you will simplify this, you will get minus 2 upon 1, which is here. Now get the simplified form of this. By substituting this point 4 comma 7 here, we can easily get the value of c, which is minus 21. By substituting c back into this equation, we have the required equation of the curve. You can take the screenshot of this solution if you want. Question number 8. In the diagram, ABC is an isosceles triangle. These two sides are equal. The point D lies on AC and ABD is a sector of a circle with center A. This arc has center A. Express the area of shaded region in terms of r and theta. This is so simple. You can easily get this area by subtracting area of this sector from area of this triangle. So area of triangle is half r square sine theta and area of sector is half r square theta. This angle is pi minus 2 theta because this is theta and this is theta, so this must be 180 minus 2 theta and 180 means pi. So sine pi minus 2 theta should be here. Now sine pi minus 2 theta is sine 2 theta. See, if this is 2 theta, then this will be pi minus 2 theta. So sine pi minus 2 theta is sine 2 theta because sine is in second quadrant and this theta is here. Let me correct this. This is the bracket. His bracket is here. So this is the expression for the shaded area of shaded region. I replace sine pi by pi minus 2 theta by sine 2 theta because of this. Now we need perimeter of the shaded region. Perimeter of shaded region means sum of the boundaries of the shaded region, meaning this R, this arc and this length. First we need to work for the length AC and then we can easily get the length AD because this length is R. We can easily get the length of DC. So we need to use cosine rule to get this length AC. Alhamdulillah Rabbil Alamin ala kulli hal. So by using cosine rule in this triangle, we have this is the cosine rule and this is the length of AC, 16.50. This length is 16.50 and something, so on. So we need DC. So DC will be this minus this length, which is here. 16.506 something minus radius will give you the length of DC. The length of the arc is r theta, which is 6. So perimeter will be this length DC, then arc dB, and then length BC. Give your answer up to 3 significant figures. You can take the screenshot of this solution if you want. Next question. Number 9. A circle has center at B. The point A lies on the circle. This is the center of the circle and this is the point A. Find the equation of this circle. First we need radius. This is the radius BA. The length AB or BA will give you radius, which is 3 root 5. And r square will be 45. This is the equation of the circle. X minus A whole square, y minus B whole square, r square. So you just need to put the coordinates of center here and substitute r here, r square. Center is at B. The next part. Point C is such that AC is the diameter of the circle. So C should be here, because AC is diameter. The point D has coordinates 5 and 16. This is D. Show that DC is a tangent to the circle. If DC is tangent to the circle, then D should be here, because this is the tangent. If D is here, then this DC is tangent to the circle. And we have to show this. You know, tangent is always perpendicular to radius. This is radius and this is tangent. So we just need to check the gradient of this tangent, or we just need to check this product m1 m2 minus 1. Well, the gradient of this line AC or BC is half, and the gradient of DC is minus 2. So when you will check these two gradients onto this equation, then you will see that this equation is verified. Half, this is m1 times m2 minus 1. So this equation has been verified. Therefore, DC is tangent to the circle. Or you can explain in words that since both the gradients are inverse reciprocal of each other, therefore DC is tangent to the circle. But the best way is check gradients into this equation. I mean, this must be verified. This is the condition for perpendicular lines. If this condition is verified, that means line is tangent. Let me write this condition here. M1 times M2 must be 1. The next part. The other tangent from D, meaning this tangent, touch the circle at E. Find the coordinates of E. Now we need the coordinates of E. This is so simple. You all know that tangents from external point to the circle are always equal. You did this property in circles in O levels. Since these two distances are equal, DE is equal to DC. So by using this property, we can easily get the coordinates of E. So the coordinates of E are X and Y. We have the coordinates of D and C. So the distance DC is here. We had under root here, and we cancelled these two roots. So this is the distance. Let me write the under root here. So by cancelling these two roots, we have this equation. See, this x minus 5 square, we have equation of circle. This is the equation of circle. So we can easily get the value of x minus 5 whole square from this equation, which is 45 minus this bracket. So x minus 5 whole square, its value is 45 minus 5 y minus 1 whole square. By solving this equation, we can easily get the value of y. And by substituting this value of y into this equation, we can get the value of x. So the coordinates of E are minus 1 and 4. I solved this equation with this equation of circle. I substituted the value of x minus 5 whole square from this equation here. This thing is important. This is the substitution from the equation of circle. Next question, number 10. The diagram shows part of the curve and its minimum point is m, minimum point m, which lies on the x-axis. Well, we need expressions for dy upon dx, second derivative, and integral. This is so simple. You all know how to differentiate this. You need to bring this in numerator first, and then you can easily differentiate this linear composite function. So this is the simplified form of dy upon dx. When you will differentiate this further or again, you will get the second derivative. This is the second derivative. Now you have to work for this. For that, you need to bring this expansion in numerator, and then you need to integrate this. Square bracket should be here with operator dx. So when you will integrate 3 minus 2, this is the coefficient, you need to copy the coefficient as it is. So 3 minus 2x whole power minus 2 will become 3 minus 2x whole power minus 1. And this minus 1 power is here, and the differential of this bracket is minus 2. And the integration of minus 1 is, this is not minus 1, this is x. So integration of negative x is minus x square upon 2. And this is the constant of integration. This is the simplified form. You can write this in this way. This is the most simplified form of the integral. So we have got all three expansions, this, and this. Now we need the x coordinate of m. For that, since m is minimum point, so at m gradient should be 0. So this is the expression of gradient. By equating this to 0 and by solving this equation, we have the value of x. Now we need area. The value of x is half. So we need to integrate this curve from 0 to half. Meaning we need to apply limits here, 0 and half. When we'll apply limit 0 and half here, we'll get this area, 1 upon 24. You can take this screenshot of this solution if you want. I think this is the last question of this lecture and this paper as well. Question number 11. A curve has equation y is equal to 3 cos 2x plus 2, and this is the domain. State the greatest and least values. Well, the greatest value will be c plus a and least value will be c minus a. So c plus a is 5 and c minus a is minus 1. These are the greatest and least values of this. I use this concept for greatest value, and for least I use c minus a. And this is the range of the function as well. If they ask write down the range, you can write this here, minus 1 to 5. You don't need to write in this situation, but this is the way to write the range. This is the extra work. Sketch the graph of this. This is the graph. You all have done this in trigonometry, so I'm not discussing how to sketch trigonometric function graph. You just need to sketch this graph from minus 1 to 5. And the mean line is 2. This is the mean line. Well, by considering the straight line y is equal to kx, where k is a constant, state the number of solutions of the equation y is equal to kx, because this thing is y. So we have to state the equation for kx, for these values of k. So in part 1, k is minus 3. So the equation will become y is equal to minus 3x. When you will draw this line uh, here on this diagram, you will get this thing. This is the equation, this is the line y is equal to minus 3x. Since this line does not intersect this curve, so there is no solution, meaning zero solutions. This line is not intersecting this curve, so no solution. Now second, k is 1. So the equation is kx. So when k is 1, this line will become x. This is y is equal to kx. See, this line intersects the curve at 2 points. So there are two solutions. The last one, y is equal to kx and k is 3. So 3x. 3x means this line. This is y is equal to 3x. And this cuts the curve at 1 point only. So there is just one solution. This question is important. I suggest you take the screenshot of the solution as well. The next part of this question, this is the function f of x, this is gx, and this is h of x. Describe fully a sequence of transformation that maps the graph fx onto g of x. So fx onto g of x. You need to observe this very carefully. See, this 2 means horizontal stretch factor half. And this means vertical translation vector 0, 4. So you just need to write, this is the horizontal transformation, this is the vertical transformation. So you can write anyone at first. Order does not matter. When we have one horizontal and one vertical, you can explain in this way or in this way. So I'm explaining in this way. Horizontal stretch factor half followed by translation vector 0, 4. Part E. Describe fully a sequence of transformations that maps the graph y is equal to f of x onto y is equal to h of x. Now you just need to observe this equation very carefully. This 2 means vertical stretch factor 2, and this pi by 2 means translation vector minus pi by 2 and 0. Again we have two transformations, HV and or VH. You can explain in any way. So translation minus pi by 2 and 0 followed by vertical stretch factor 2 or vice versa. You should take the screenshot of the solution as well. You should be good at transformations. Otherwise, you won't be able to recognize these things easily. I hope this lecture will help you to understand how to solve the questions of P1. An important advice for me and for everyone: be of benefit to others. Good luck. And I'm extremely thankful to Miss Ramsha, who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. May Allah Pak give her the best grades. Ameen. Allah Hafiz.